My fellow scientists and mathematician, thanks so much for your interest in studying maths. We are dealing with complex for the here student, and we are in complex maths. So that when you have cos bracket, conjugate of z is the same as conjugate of cos of iz for any z. So we let our z to be x plus iy and our complex of z to be x minus iy. Then we note that cos iz, instead of z, we substitute z with x plus iy. Whereby now, when you multiply with I, you will have ix. I squared is negative, so that's why we have here negative y. Then from there now, cos conjugate of z is equal to this part here. Now, when you introduce, so there is a negative. So cos conjugate of z, this part here will change and it will become a positive. So that's why here we have cos conjugate of z. So the negative changes into positive. Then we use this sum of cos identity, the sum of cos identity to expand this. And we are going to have cos of ix multiplied by cos of y minus sine of ix multiplied by sine of y. Then we note that sine ix is the same as a parabolic cos x, and sine of ix is the same as a parabolic sine of x. So we substitute up here. Instead of sine ix, we write a parabolic cos x, and instead of sine ix, we substitute it with sine a parabolic of sine x. When we do that, the result is hyperbolic cos of x multiplied by hyperbolic multiplied by cos of y minus I sine of x, as multiplied by I sine hyperbolic sine of x multiplied by sine of y. Then we take conjugate of the given taking conjugate of the given function. It follows that so we have cos minus hyperbolic ix minus y. So negative can be taken out, which is negative cos negative ix plus y. Then we expand this using the sign identity, and when you expand, the result is as shown here after expanding and making the substitution that sine ix is the same as a parabolic cos of x. Also, this negative has disappeared because cos is an even function. It is not affected by negative. Then to obtain this result, clearly when we compare hyperbolic cos of I, when you compare now cos, when you compare cos iz conjugate, it is equal to conjugate cos of iz as indicated there. So thanks so much for your precious time as we have taken you through this complex equation. For more such learning, kindly tune on to my YouTube channel so that you may keep on learning. If you have not yet subscribed, kindly consider to do so that you don't miss a single video which I upload for us now and then, as we keep on learning this important concept of mathematics.